Chapter 7, Planting by Daniel Dean. Soil preparation for planting potatoes should be such as will meet the peculiar demands of the potato plants. A loose and mellow soil is needed for extension of the weak and tender roots and for the development of the tubers. Preparation should be designed to correct the faults of the local soil and climate as far as that can be accomplished. Preparation before planting should be such as will reduce the tillage after planting as much as possible. Weeds are more cheaply killed by wide-spreading tools like harrows and discs than by small single-roll tools or by hand hoeing later. Fall plowing is of great value in all but the lighter soils. It rots the soil organic matter, puts the land in better physical condition by exposing the bare soil to winter freezing, stores up more water for the use of the crop. I don't know about, we've learned quite a bit. So remember, this is a 1917 book. We have more recent research. But for historical purposes, this still may be interesting. Rots the organic, puts the land into better physical condition by exposing the bare soil to winter freezing, stores up more water for the use of the crop, and sprouts and kills part of the weed seeds in the ground. The control of insects, like the white grub and wireworm, is easier with fall plowing because the larvae are more exposed to freezing and to attacks of their natural enemies, such as birds. I don't know about that. As a rule, the heavier a soil, the more it is benefited by fall plowing. Well, probably the more compact the soil, the less healthy it is. There is some saving in labor by fall plowing in the northern states because potatoes are usually followed by spring-sown grain, which requires considerable work early in the spring. The harrowing needed to place fall-plowed land in condition for planting takes less time than spring plowing and the harrowing necessary to cut up the sod well. Harrowing must be deep and thorough, or the benefit of fall plowing may be largely lost. While there is some additional loss of moisture from plowing a second time in spring, this later plowing greatly reduces the amount of harrowing necessary and makes certain that the soil is well pulverized to the depth of the furrow. It is well to fall plow land as roughly as possible with the furrow slice standing nearly on edge. By the way, I personally lead to no-dig farming, so anyway, a rough surface catches the rains better, exposes the soil better to the action of frost, and reduces the damage by winds through the winter. If you want to preserve the soil life, you actually want to do the opposite of this. Water is saved in fall plowed soil because the layer of sod or trash at the bottom of the furrow prevents the water in the subsoil from escaping as readily. Straw or manure spread on the surface before fall plowing will usually become rotted enough by spring to give little trouble if replowed. The mellow soil with rotting organic matter holds more water than unplowed land would. Well, that's true, especially in places like dry knolls. Clover sods rot quickly, but sods of the grasses take longer. With spring plowing only, it is beneficial to cut up the grass sods with a disc harrow before plowing. The sod rots more quickly and the soil settles together better so that the movement of the water in the soil is not hindered. Earliness is a great advantage in spring plowing in the northern states. An experiment by King at Wisconsin showed that water equal to 1 3/4 inches of rainfall was evaporated in 1 week in spring. Water evaporates from the soil very fast in the first days of spring after the frost goes out. This water can seldom be fully replaced by later rains. Its conservation may often turn the scale between success and failure in droughts late in the season. Fall plowing has here an advantage over spring plowing because it is possible to cover many acres with harrow or disc in a few days as soon as the... You know, if you're plowing, you're probably going to lose more water, right? So this contradicts, I think, a little bit with what was said before it. Because it is possible to cover many acres with harrow or disc in a few days as soon as the ground can be worked without injury in the spring. By going over fall plowed potato ground once before sowing spring grain, the saving in moisture for the potato crop will more than pay for any loss of grain by slightly delayed sowing. Tillage tools. The plow is the standard implement of tillage, except in special cases. Nothing has been found to equal its work. The common plows used in the east and south are drawn by 1, 2, or 3 horses or mules. The 2-bottom reversible sulky plow is coming much into use in the east. It is heavier and more expensive than the common plow, but will work better in soils of varying hardness, and in plowing alfalfa sod. This reversible sulky plow, like the ordinary 2-bottom gang sulky used in the Central West, does poor work in plowing under straw, stalks and the like than the ordinary walking plow. The plow can turn under sods and so forth more perfectly than any other tool, and its use distributes surface organic matter. The jointer enables sod and trash to be buried more completely. The type of harrow to be used depends upon the work to be done. Harrows may be used merely to fine and smooth a rough surface, like the spike-tooth harrow, or may be designed to tear up and fine the soil to considerable depth, like the disc and spring-tooth types. The disc and its variation, the cutaway, are used most in soils nearly or quite free from stone. With these, the soil can be thoroughly fined nearly to the depth of the plowed furrow. The disc will cut up sods or straw and will work in soils so full of weed roots that other types of harrows will be clogged. The spring-tooth harrow is used more than the disc in sections with stony soils. It pays to keep the cutting edges of the disc or the points of the teeth sharp. The spike-tooth smoothing harrow should follow the disc to level the surface before planting. It is also valuable to keep a surface mulch before planting and to kill weed seeds that have sprouted. The roller is a tool of great value, but is often used with poor judgment in potato growing because it has considerable weight for the small surface. Its action resting on the soil is to firm the earth to a considerable depth, something seldom necessary with potatoes unless on very light soil, and is often harmful. Used to follow the plow after plowing in the spring, it may help to prevent sods on edge from making open spaces in the soil. Too often it is used with the idea that it is necessary, as with the grains and grass seeds, to firm soil around the seeds to furnish moisture for germination. Firming the soil around the seeds also increases the contact of the soil with the seeds. The roller, I'm adding some stuff in here. I hope you don't mind. The roller is used to assist the germination of grain and grass by packing the soil around them, causing it to become damp by the capillary rise of water. Such seeds are dry and need water to start, and their small size demands closely packed soil for the benefit of the roots. Unlike the dry grain seeds, the large potato seed pieces have all the water they need, 80%, and can grow for weeks without any from the soil. This fact is familiar to those who have seen potatoes in cellars send shoots to the length of several feet. Soils are seldom too loose for the potato and are very often too hard. The plank float or clod crusher is a better tool to crush lumps and does not settle the soil below the surface as does the roller. Such lumps crush easiest the first few hours after a rain. The depth of plowing for the potatoes should be as great as the fertility of the soil will permit. The weak potato roots need all the space they can get. Outside of the arid regions of the United States, care must be taken not to expose much of the cold and infertile subsoil at any one plowing. Where it is necessary to plow land deeper than formerly, not over 1 inch of subsoil should be turned up at a time. Organic matter must be added to lighten the subsoil turned up, as it is very deficient in this. Sandy soils in which potato roots penetrate easily need deep plowing less than heavy soils. Only 3 to 5 inches is used in some sandy sections. Heavier soils, if well provided with humus, are frequently plowed to the depth of 10 inches or more, usually about 6 or 7 inches. So the question is, with this old stuff, if you build the quality of the soil, do you need to plow it at all, right? Results of tillage. The results of soil tillage are 1. The organic matter in stubble, manure, and the like is buried in the soil to decay there. 2. The mineral particles are made finer and fresh surface exposed to the action of solvents such as soil, water, and carbonic acid. 3. The soil organic matter is broken up and easily changed into more useful forms. The rapidity with which soil organic matter is destroyed by tillage is little appreciated. The common saying that tillage is manure is practically true. Tillage is expensive in labor and also expensive in the changes it produces in the soil. A soil thoroughly tilled for a potato crop has thereby lost a considerable amount of organic matter. People remember the organic matter is what helps with water storage in the soil, for example, and encourages the life in the soil. The expense of replacing this must be considered in the final profit and loss account of the crop. In many parts of the United States, potato growing has gained a bad reputation from the rapidity with which it reduces the fertility of the soil. In others, where organic matter is kept up by good rotation and where fertilizers are used heavily, potato growing is regarded as a sure way to enrich the land. A single tilled crop, like potatoes or corn, places the soil in better physical condition to grow succeeding crops of grain and hay. I don't know about that. The alternation of tillage crops, which excite and increase bacterial activity with the hay crop, will provide organic matter as a food for the bacteria and thereby keep up fertility at low expense. So you see, even here they realize the importance of the bacterial activity. 4. The increase of the volume of the air spaces of the soil by thorough tillage greatly increases the chemical and bacterial activities of the soil. The oxygen of the air combined with the organic matter of the soil causes the formation of carbon dioxide. This, in turn, acts with the soil water as a solvent of mineral compounds such as insoluble phosphoric acid. The beneficial bacteria of the soil are favored by plenty of air in the soil and increase greatly in number and activity. Their action increases the availability of the soil plant food. Some species of soil bacteria are injurious, as these mainly thrive where little or no air is present. Tillage reduces their effect. Something could be said, for example, by worm action in the soil as well, which tillage would probably interfere with. 5. Tillage exposes fresh soil surfaces to the air and at first causes some loss of moisture. Notice that tillage causes some loss of moisture. Loosening the surface soil by tillage prevents evaporation from the lower parts of the soil by breaking up capillary connection between the soil under the tilled area and the surface. I don't know, that doesn't sound right. Until capillary action is again established by the settling together of the tilled soil, but little water can be lost by evaporation. No, a lot of water can be lost, actually. A thin layer only of loose soil is sufficient to prevent evaporation. A thin layer settles together sooner than a thick one and needs breaking more often. More emphasis has usually been placed on tillage of potatoes after planting than before planting. The great soil supply of water in late winter and early spring presents opportunities for conservation that exceed those during the growing period of the crop. In recent years, a change has come about in the attitude of investigators towards the value of summer tillage. Extended experiments have shown that one factor which was largely neglected by early experimenters is of importance. This is the ability of the plant root to seize upon the use of soil moisture. When the soil is not occupied by a growing crop, there is no doubt that a surface mulch of loose soil does conserve moisture by preventing evaporation. But when the soil is well filled with plant roots, there is little more water evaporation from untilled soil than from tilled. Plant roots in the soil do help. They also provide organic matter. The gains in yields observed from tillage come from another source, weed killing. Okay, but you can crowd out weeds too, rather than from prevention of the evaporation. This means that the farmer will till practically as much as under the former practice, but will have in mind weed killing as his principal object instead of preventing loss of water. In practice, this will mean that the tillage of the potato crop during the growth of the crop will be done earlier than has been the custom. Water will be conserved by fall plowing where possible, by the addition of organic matter to the soil, and by early spring tillage to save the water supply. So a lot of this, I think, there can be a lot of discussion on what this is saying. But remember, this is from back in 1917. The soil will not be allowed to dry out for the late main crop of the northern states before planting. All this early tillage also kills many weeds, which have formerly been left to be killed by intertillage later on. After planting, there is a period of several weeks when large and wide tools can be used to advantage in tillage. The harrow, leveler, and weeder cover several planted rows at once, and kill weeds very cheaply besides saving moisture. So I don't know about how much moisture that saves. The necessity of weed killing for the production of large crops is even greater than the saving of moisture by tillage. Well, that's debatable on how important the moisture is, right? Weeds not only rob the potatoes of moisture, but are able by their stronger root systems and greater foraging ability to seize upon and use the soluble plant food in the soil. Very small weeds in this way injure the potato crop more than would be supposed. The weeds which sprout from seeds in the soil are more easily killed before coming up than afterward. The tender shoots from the seeds are killed by a light stirring of the soil, which would not affect them at all a few days later. The sprouts starting from the seed have but little vitality until they can reach the surface and produce green leaves. Then roots start to secure plant food, which is worked by the leaves into material for further growth. It's interesting to think how they came by these understandings back in 1917. Every day now adds to the ability of the young weed to stand punishment and live. Several successive crops of weed seeds can be sprouted and killed by tillage between planting and the time when the potato tops are 6 inches high. Tillage at this time can be done carefully enough to prevent injury to the growing sprout of the potato before it comes up and until it is established for itself in the soil. Perennial weeds with rootstocks, like quack or witchgrass, are much easier controlled by previous cultivation in the fall or early spring than by tillage during the life of the potato. The reserve of nourishment in the rootstocks enables them to stand punishment for several weeks, and recover from it to injure the potato after tillage is no longer possible. The preceding results of tillage have all been favorable to the potato plant. Tillage has another action which has not been sufficiently studied and which has led to many conflicting results in experiments and in farmers' practice. It is a fact that tillage can injure the potato plant even easier than it can the tough and hardy weeds. It is very difficult to work with soil near the potatoes without injuring them. As the season advances, this becomes more dangerous to the potato. While the young plant is still attached to the seed piece and drawing on it for nourishment, it can lose part of its small roots without great loss, particularly as the weather is yet cool and favorable to the vitality of the crop. Each day the potato grows older increases the danger of loss of yield from injurious root injury. In the later part of the plant's life, the whole upper soil becomes filled with roots. These come so close to the surface that it is most difficult to work any tillage tool without some injury. So there may be an argument here for no tillage at all, right? So again, this is from 1917, these suggestions. Few tools except the hand hoe can be worked as shallow as 1 inch, and many of the larger roots are that close to the surface. Under some conditions, late tillage may do less injury to the potatoes than under others. In periods of abundant rainfall, the plants may tend to root too close to the surface, and some root pruning may force the potato to root deeper. If drought comes later, this will be a benefit to the crop. In very cool seasons in which a potato does not suffer from extreme heat, root pruning by tillage tools does less damage than in hot and dry seasons. The loss in yield from tillage at the wrong time, too deep, or too close to the plants often amounts to a large percentage of the crop. The greatest danger from excessive tillage is likely to come in the northern states, in which late cultivation of the main crop comes at the hottest time of summer, when the critical period of the plant's life comes at the time when climate conditions are most unfavorable to the potato. Any injury to the roots is likely greatly to reduce the yield. Planting. The time of planting depends on the market for which the crop is grown and the local soil and climate. The higher prices received for extreme earliness in the southern truck crop compel the use of short season varieties like the Triumph and Cobbler, and planting very early to get the crop on the market before prices fall. All cultural methods are arranged with this end in view, so there is little choice in the time of planting. Along the Canadian border and in much of the Rocky Mountain section, the whole growing season is but little longer than the life of main crop varieties. But in most of the principal growing states, from New England to Iowa and Nebraska, it is possible to vary the time of planting by several weeks. Here, as a rule, most potatoes are now planted in late May and in June. The later plantings yield better because the crop matures in cooler weather than with early planting. Moisture is more likely to be abundant in fall than in late summer. The dangers of late planting are late blight and rot. Unless spraying with Bordeaux is practiced, I don't know what Bordeaux is, injury from early frost and early fall freezing of the soil, and conflict of the later tillage of the crop with the rush period of haying and harvesting, but increasing competition of the southern crop is forcing many growers to abandon the previously profitable early crop for local trade. Bordeaux spraying has been found to lengthen the life of the potato, and potatoes to be sprayed may be planted slightly earlier than those unsprayed for that reason. So looking on the internet, Bordeaux Fungicide is 1 gallon of water, 3 1/3 tablespoons of copper sulfate, and 10 tablespoons of hydrated lime. Sounds like you need that for unhealthy soil, because fungus can actually be healthy for the soil and is necessary. So yeah, this 1917 thing is historical. So it has some interest, but we've learned a lot since then, I think. The methods of ridging and level culture with deep and shallow planting are best illustrated by their use in two of the best-known potato-growing regions of the United States. Ridge culture with comparative shallow planting is used in Maine. The northern latitude of Maine makes the growing season short compared with the southern states. The mean temperature of the month of July is only 62 degrees to 65 degrees. Frosts are frequent in June and September and may occur in August. Not much field work can be done before the month of May. October 10th is regarded as the danger line beyond which potatoes are likely to be frozen in the ground. Only a short distance away in the Atlantic Ocean, the cold ocean current from the Arctic reaches the warm Gulf Stream. The fogs of the fishing banks here are well known. The rainfall is heavy and is seldom deficient throughout the growing season. The rainfall of winter is largely available to the potato crop. The ground is covered with snow all winter, and the loss by runoff and evaporation before time of planting is much less than that of the other grape-producing states. The soil conditions of Aroostook County, the grape potato-producing section of Maine, are favorable for the retention of soil water, Most of that section has been cleared from the forests only a few years, compared with the longer settled communities, and the soil is well supplied with organic matter. The region is so damp that the higher and drier parts are usually considered safer and better for potatoes than those lying lower. The more or less gravelly limestone loam soil crumbles easily and seldom gives trouble by baking. With such conditions under which surplus of water is more to be feared than a deficiency, Maine growers use an extreme ridge culture. Instead of leveling down the ridges left by the planter and depending mainly on the use of leveling tools and the weeder to kill the weeds sprouting among the plants in the row, Maine growers kill the weeds in the row by ridging several times. There is little danger that the growing plants in the ridges will suffer from lack of moisture. Ridge culture is also the favorite in the adjoining provinces of Canada, in which conditions are similar. This culture is suited to wet climates and wet seasons. Digging is rendered easier by ridging where the soil is likely to be wet. The first ridging after the plants come through the ground covers the small plants and prevents injury from late forests. In many other sections, such covering would result in baking the soil. Ridging is necessary under the methods of irrigation in order to prevent injury to the potato plants from the irrigating water. Long Island potato growing stands as an example of prosperous farming, where a different method than the ordinary is used. The soil of Long Island is a rather light sand which is easily tilled and dries out quickly after rain. Level culture is used because much better yields are secured than by ridging. Less soil surface is exposed to evaporate water by level culture. Partly owing to the high prices in late summer, Long Island potatoes are planted as early in the spring as the ground can be worked. Last of March and April, and mature in the dry weather in July and August, deep planting and level culture exposes less of the easily heated, sandy soil to the sun and reduces danger of heat injury as well as that from drought. The light soil usually is dry at digging time, gives little trouble in digging, though sometimes fields left late before digging are ridged to kill weeds which have started. Level culture is a relative term as some earth is thrown toward the plants by the teeth of the cultivators. This prevents the growing tubers from being sunburned. Deep planting allows the soil over the rows to be thoroughly worked in the weeks subsequent to planting. Weeds are easily killed at this time and soil water conserved for the later use of the crop. As a rule, early planted potatoes should be put in shallower than late potatoes, as the sprouts start more slowly in the cooler soil. Very shallow planting is seldom advisable unless the soil is so wet and cold that heavy ridging is necessary for drainage. Growers in other sections of the country use methods between the two extremes, according to their conditions. The truck crop of the South is raised under soil conditions similar to those of Long Island. The need of securing warmth in the soil to hasten growth leads to some ridging. Shallow soils with hard pan close to the surface, as in the Volusia soils of New York, Pennsylvania, and Ohio, present a hard problem. Ridging is the usual method used in this section on account of trouble in digging in wet seasons. And with the usually stony soil, it is difficult to control weeds near the plants by the use of other tools than those which ridge the rows. Light and dry soils particularly, if likely to be fairly dry at digging time, do better with nearly level culture. The advantages of having sufficient soil over the seed to permit wide tillage after planting are so great that it pays growers to plant deep enough for this purpose. The bottom of the furrow made by the planter or marking tool should be at least 2 inches below the level of the surface of the soil, and better 3 or 4. For sandy soil likely to be dry, even more. Growers are often deceived at the depth they plant by looking at the depth of the mark below the level of the earth thrown out by the marking tool, instead of taking the measure from the true level of the surface soil to the bottom of the furrow. Hill and drill planting. 2 principal methods of planting are used in the United States. Potatoes are said to be in hills, checks or squares when the ground is marked both ways and the seed dropped at the intersection of the mark. This method is much used for hand planting. It has the advantages of permitting cultivation both ways, and so weeds are easier kept under control. With poor soils, the large area allowed to each hill is an advantage, as each hill has enough space to produce a good yield. Rows in the United States are from 30 to 42 inches apart, according to the value of the land, the amount of stone in the soil, and according to the fertility. Unless the ground is very poor, it is advisable to have the hills closer together in the short way of the field to give a large yield. When planted in drills, the seed is planted from less than 12 inches apart in the row in the best soils to sometimes nearly 2 feet in poor soils. Planting in drills is rapidly gaining ground in the United States as the yield from the larger number of hills is larger to the acre than when planted in hills. Growers in all the important potato growing sections find it practicable by modern tillage methods to keep weeds subdued in drills as well as in hills. The prices received for potatoes from sections in which drill culture is general are higher than from those where hill culture is mainly used. City markets demand medium-sized tubers and pay better prices than for the coarse and overgrown tubers raised in hills. When machine diggers are used, digging costs the same when either method of planting is employed. With hand digging, the larger number of hills to the acre under drill culture takes more time to dig than with hills and may reduce the acreage by limiting the amount which can be dug before freezing weather. The constant improvement in the manufacture of diggers is producing machines that will dig in very stony soils. The general rule for spacing hills is to vary the number of hills to the acre according to the yield which may be expected. As the distance apart decreases, the weight of the individual hills and the size of the tubers is reduced, and the total yield to the acre is increased. The cost of planting and digging may be increased. Digging close planted hills is rather expensive. The smaller size from close planting brings higher prices in city markets. An extreme case of close planting is that in the island of Jersey, where potatoes are planted 12 by 16 inches or over 32,000 hills to the acre. With very rich soil and hand tillage, a yield average over 400 bushels to the acre is secured, even when dug for the early market, while still growing. The type of the potato variety affects the spacing. The common rural or blue sprout type sets fewer tubers to the hill than the green mountain or white sprout type and should be planted closer on that account to prevent coarseness, a common fault complained of the city buyers in rurals. Early types of the Bliss Triumph and Irish Cobbler are usually planted closer together than late varieties. In Europe, it is a common practice to use small tubers uncut for seed. These are often secured by planting very close, sometimes as little as 6 inches apart in the row. As before noted, wide spacing allows faster digging on stony soils. Regions of intensive potato culture, such as Maine, Long Island, and the coast trucking region, usually plant rows 30 to 36 inches apart, and the seed drop 12 to 16 inches apart in the rows, or 12,000 to 16,000 hills to the acre. Regions with stony soils, as the Steuben County and Chateauguay sections of New York, Steuben County and Chateauguay sections of New York, plant to some extent in checked hills about 3 feet each way, or less than 5,000 hills to the acre. The regions where the expense for rent of land, fertilizer, and care are high use close planting, while low-priced land with other small expenses allows more space to each hill, which may be of value in bad seasons.